I'm talking to Andreas Thiel, who's the co-founder and executive director of product centers at u-blox. Andreas, hello.
Hello, Nitin. Nice to meet you.
Good. Tell me about some of the big issues that are bothering you right now.
Well, today I'm very pleased to talk about two solutions to two big issues that we see. And if you look at our business, we have on the one hand we have this side of positioning, where we look very much into bringing centimeter level accuracy to the broad market, and we call this democratizing high precision for many users. So this is for us really a big industry trend in this area. If we flip over to the cellular domain for a minute, there the big trend is the rise of satellite-based communications. We see this as a trend now that, especially in the industrial IoT domain, our customers like to have coverage even where a cellular network, a terrestrial cellular network, is not present. So there's a lot of activity going on in the domain of how do we back up basically the terrestrial connection with a satellite-based connection. So these are the big trends, I think.
Okay. Let's talk a little bit about democratizing high precision positioning. What does that actually mean? Because I thought, and maybe a bit of ignorance, I thought, there's positioning in pretty much every device.
Yeah, actually, me now being in this business for more than 25 years, it's indeed a very interesting journey, because we many times came to the point where we thought, well, satellite-based positioning came to a natural end of evolution, but then there was always another step coming as the next steps. You may remember in the early days, 25 years ago, a GPS receiver was maybe something you would have on an airplane or in very expensive equipment. We then saw it proliferating into the mobile phone, bringing it into the hand of everyone, and also into automotive navigation. We saw it going into high sensitivity acquisition, so bringing it to
So
more
the automotive navigation, that was an era of the TomTom and that kind of.
Exactly. That
Okay.
was TomTom's coming up, and now, of course, it's a default feature in all the cars. You have it in a dashboard. You don't need a TomTom anymore, or you can just use your smartphone, which, every smartphone has a GPS inside or GNSS receiver. So I think that was already a first step, bringing really satellite-based positioning to the masses, but it was at the time still the, let's say, meter level accuracy.
Okay.
So that is helpful for many, many applications, but of course, a totally new field opened up when we brought our F9 product to the market about 5 years ago.
What's F9?
F9 was our first multi-frequency product, which enabled a kind of a decimeter accuracy in certain environments. I think the big step there was to bring technology that was available before for very specific applications in precision agriculture, for example, in very expensive equipment with very expensive service subscriptions.
Like John Deere.
Like John Deere, we know also the likes of Topcon, for example, in construction equipment, and
yes.
There are others in this area. So this is typically equipment you attach to $100,000 worth of equipment, and then of course the pricing of the technology for positioning doesn't matter that much, because you massively increase the efficiency of the use of that equipment. With F9, for the first time, we brought this type of technology to price levels that you, for example, can put it into a lawnmower, autonomous lawnmower. Or maybe also into a scooter or other types of autonomous robots. So really bringing it down to a pricing level that works with this type of equipment. And I think also the other aspect was interest in the automotive industry to get higher precision than what was available with standard GPS or GNSS solutions. To get this to the automotive space, and you can imagine that also there the pricing levels of I mean, multi-$100,000 equipment doesn't work really well to bring it to the automotive industry. And I think this was enabled with F9 for the first time to get in this direction. But there is still a lot to do with the F9 technology. For example, we have typically the need for correction service, which we also offer. We call it Point Perfect. In that case, you get typically a regional coverage. So for a continent, for example, United States or Europe or certain regions in Asia, but it's not a global coverage. And it is still a bit, I mean, you have some hurdles to pass to make it work. I mean, we lowered these hurdles a lot. But with the X20 technology, we really make centimeter level accuracy available globally, and it simplifies things because it can access correction data through L-band directly from the satellite systems. We have a service that corresponds to that, so that brings you out of the box without worrying about specific subscriptions, regional performance, and so on. Gives you this performance just everywhere in the world, and you can just start it and
so
run.
what kind? That's a subscription service.
Yes.
So you can subscribe to sort of it being connected everywhere. So it's like a connected SIM almost.
Yeah, we actually, I mean, also for a very long time, these services have been made available through two different means. I mean, one is just an internet connection. So if your device is connected, which is obviously the case in many use cases, you can just subscribe to a service via internet. And the other alternative is satellite communication. So there are, for example, our Point Perfect service is also available through an Inmarsat satellite link. In the F9 platform, if you wanted to use it, you needed another piece of hardware to receive that satellite signal for the correction service. Now in the X20, this satellite receiver is fully integrated in the same chip. So it just runs out of the box and you can receive the signal. That makes it a lot simpler for integration.
And the X20 you referred to is something you've just recently launched. Is that right?
This is exactly, we launched it at Intergeo. We did, so that was a week ago. And there we could present it. It's already with first customers for testing. And so that's really the next big thing in our roadmap to a high precision GNSS.
And customers testing. So what kind of areas? Is that automotive right now, or is it your sort of high precision equipment, or yeah, what kind of areas can you say?
Yeah, it's I mean, I mentioned already the main drivers for high precision technology is in the one is the automotive domain.
Yeah.
Where it's really helpful for all kind of assistant driving systems. So we're not necessarily talking about fully autonomous driving, but also ADAS level 2, or what people call now 2+. So the more enhanced assistance systems, they all benefit from at least a lane accuracy, which means even under difficult signal conditions, you want to have something like half a meter accuracy. Typically, we talk about decimeters, so 10 centimeter accuracy. It's not that you want centimeter, but you want reliable and dependable decimeter accuracy for these use cases. So for that reason, we see increasing demand in the automotive space for something better than standard GNSS, and that's typically requiring high precision. And we can bring this scalability to the market. Also with our other products, we have then a full roadmap where you can basically start at a standard precision GNSS solution, go to the high precision, add our service offering, and at the very high end, if it goes to really autonomous driving, we can also extend this to an offer. This is not the X20, but we have other offers that also offer a safety certified solution here if there are safety goals to be attached to the GNSS receiver.
So the key here, sorry, go on.
But that's the trend in automotive we see, where in the past, let's say GNSS was mostly used just for navigation and also used maybe for emergency call applications. Now we see this more and more being integrated also in driving assistance functions, where you want to understand which lane am I on, what is exactly the layout of the road, and you need something better than a good meter accuracy to understand what is the scenario the car is in.
And that's the one where you're offering centimeter level accuracy or meter level? Sorry, I thought you just said meter
Yeah,
level.
I think the important part here is more not the absolute precision, but the global coverage.
Okay.
Because
Right.
here, I think what makes life much easier for our customers is that in the past they have to consider which continent is this car going to,
Okay.
which service do I have there, which subscription do I need, and so on and so on. Now we can say, okay, there is a basic layer of service that gives you this centimeter accuracy just globally, and you don't need to
So
worry
a company
about.
like Stellantis or General Motors can do one model that covers maybe different territories. Is that what?
Yes,
It's
yes, it was, let's say in the past with F9, it was always the same hardware, which supports all kind of services, and you could do the software integration, but still you had the effort to think about each location and easily, I mean, some of the areas are easily covered by many providers. Also, u-blox has this offer in the point perfect context, but then you may have these corner cases, and one important corner case obviously is China,
yes.
which is a very important market, but from the service perspective is a very local market. So because
Okay.
that's managed obviously by China government, and so there you have typically different providers than in other areas of the world. So that's one of the areas, and you can imagine there are also a lot of smaller countries, thinking of Africa, South America, and so on, where this whole picture is a bit more fragmented.
So if a BYD, for example, is producing cars for China and global markets,
Yeah,
they will still use something like this for that global coverage, or they'll need something separate for China.
they could today with the X20 offer, there is they could use a global PPP service, which is helping them and is delivering the accuracy they need for this automotive application, or they could go to local services, and then it's typically one service for China and another service provider for the rest of the world for all the overseas markets. That's the typical setup that we see today.
So essentially, your new offer is the X20 is centimeter level accuracy and multiband.
Yeah.
What sets you apart from competitors? I mean, is where do you sit in the sort of whole landscape for positioning chips?
I think with this product, we are really in that kind of pricing level. We are absolutely best in class. I think in all dimensions, if you look at, we don't just say multiband, we really say all band. So all the signals you can think of today, they are
Sorry about
supported.
that.
all the satellite systems are supported by the system, and plus the satellite systems, as I mentioned, is also the L-band channel is supported for getting correction signals from systems like Inmarsat, for example. So it's really a system that uses all satellite signals that are available to create the best possible location. And then you can go into other dimensions. We can talk about power consumption, which is very low for the performance level that is delivered. We can talk about size of the solution. It's a single die. It's one chip that does it all. And so there are many aspects that set it apart from competition. I think it's really a breakthrough product here that delivers everything you can imagine for this kind of application. And I think we talked a lot now about automotive. If you push the envelope more towards precision, like in agriculture or construction, I think there it's nice that while let's say the global PPP services that we talked about deliver this global coverage, they may not deliver the ultimate precision in every location. But if you go then, if you want a higher precision, you typically go to what we call RTK service or virtual
Yes.
RTK services. And of course, also these services are supported by the X20 platform and also offered by u-blox as a service offer, but also by others. And there you can then really get to this centimeter precision in locations where such services are provided.
Okay.
And I think that gives you this full flexibility with this platform to really adjust to the precision needs that you have and to the coverage needs that you have.
Okay. And tell me a little bit about non-terrestrial networks then.
Yes, we have seen it. I mean, we have a very strong foothold in the industrial IoT domain. I mean, tracking of goods, containers, trains, and so on is really at the core of our cellular business. We are very strong in Cat-M, Cat-1 bis, so let's say the low categories of the cellular standards that are being used in IoT, low data rate technologies there. And obviously there was always a need to extend somehow the coverage because I mean, obviously the global network operators, they tune the network to have a very good coverage where the people are, but this is not necessarily the same place where the things go that you want to track. Imagine containers in a ship on the ocean. I mean, obviously there's no cellular coverage, but we have also animal tracking in rural areas. We have a lot of applications where the Internet of Things, where the things are in places where no people are, and there's typically no coverage from cellular networks. So there was always this need to have some fallback solution that works where cellular doesn't work. And I think that's really a great opportunity we have here because our own cellular platform, the R5 platform, this platform offers us, thanks to its architecture, to also support various satellite technologies. We started this a while ago because we tried to use a satellite technology that is already available in widespread use. So we teamed up with our customer Orbcomm. And I think that was a press announcement already a while ago that basically our R520S is the product. It supports the Orbcomm satellite connectivity. So users who have an Orbcomm subscription can basically use this system as a fallback. And the nice thing about this is that's an established infrastructure. Orbcomm is in the market since ages. It's proven, it's robust, it's working, and it's there. And the commercial models are very clear. So for customers who want satellite fallback connectivity today, they can make a choice and they can select something that's working and that's out there in the field. And I think that was the good thing about this first product in satellite, and we see very good customer traction there. Now, the thing that we announced now lately is the first product that supports the 3GPP standard for satellite communication. So it's basically an extension of what we have on terrestrial cellular connectivity to the non-terrestrial network. So that's where the name comes from, NTN, non-terrestrial network. But that's part of 3GPP release 17 specification. So the idea was also there basically from the 3GPP domain that extension to the satellite systems could be highly desired for many of those IoT use cases. And so that is there, the standard is there. We see also companies like Skylo adapting these standards, but of course that's all in deployment right now that's in development. We see, as I said, Skylo is probably one of the first who is able to also do certification. So we are working very closely with them to make sure our modem works with these early NTN deployments, and so we take it from there. So that's basically an offer for our customers who want to embark on this now basically a growing NTN ecosystem that is going to come.
All right. Let's just final question. What are the things that are on the horizon in terms of your technology strategy, business strategy?
Yeah, I think on the let's keep it for a second on the cellular side. Of course, there is the question, when will the IoT world fully embrace 5G?
Okay.
I think, I mean, 5G almost sounds like an old thing if you think about your mobile phone or smartphone, but on the IoT side, of course, we have the situation that inherently by the standard Cat-M and narrowband IoT are 5G standards. So they continue in the 5G domain. But there is a question, where will, let's say, the performance level that is slightly above, like Cat1, Cat4, which is also being used in a lot of IoT applications, what will be the future of this one under a 5G umbrella? And so we see there, I mean, there's also Release 17 especially is interesting, the RedCap, reduced capability in 5G, and we are looking towards this to become a commercially viable product. I think that's here really the hurdle that we have for entry into the 5G domain. Over the years, LTE technology has been very much cost optimized for the IoT use cases. Cat1 is one of the more recent steps to further reduce the hardware cost and still deliver kind of Cat1 full LTE performance to IoT applications. And there's, of course, a question, when will 5G technology reach a pricing level that you can really do this step forward from LTE technology to 5G? And that's the promise of RedCap, especially in Release 17. And we are looking forward to products coming available, and that will then bring us also in IoT into the 5G era. I think that's what we're pretty much looking forward in cellular. And on the positioning side, of course, we have talked today a lot about high performance. High performance is important. And I mean, we are really looking forward to all the applications that are developing. I mean, no one, if you had talked to people 10 years ago, probably no one was thinking about a lawnmower that is autonomously driving in your backyard based on satellite navigation. These days, this is possible. I think there's a lot of applications will be enabled by this, by being able to determine your position with this high precision that we may not even have on the radar today. So very much looking forward what is developing there and how we can further shape our products to support. But I think there's also another area we talked in the very beginning. We talked about bringing GNSS to smartphones. I think there's also a question, what will happen if we can bring this high precision, high performance technology to power consumptions that make it viable also for wearables, for mobile phones. I think there's also, again, then another shift probably waiting for us if this technology gets really into the consumer mass market. And we are very much looking forward to this one.
Okay. I mean, that was a final question, but another final question. What's the most unusual application that you've seen for positioning?
The most unusual, I mean, from the log files we see, the most unusual is drop zones for people who try to analyze tornadoes from the top. So they fly with an aircraft over the tornado, and then they drop zones that will swirl around with the wind, and then they send data from the inside, so to track and help the scientists to understand what's going on inside. And
Okay.
if you look at these log files, they are really interesting to watch
Okay.
because you see dynamics that you wouldn't believe that they are possible
Wow.
in all
Okay.
three dimensions. And that's for me personally one of the most unusual
Okay.
applications.
I'm sure that's available on the internet for people who want to find out more about it, I guess.
Yeah, I think that's probably from the scientists. I think it's typically the unusual. I mean, just imagine the drones that we use today to take pictures and so on. That was a very unusual application, maybe also 10 years ago with the rise of certain players in that market. Nowadays, everybody has one.
Yeah.
Yeah, that was a very, very unusual one before. Yes.
Well, good. Well, Andreas, thank you very much.
Thank you, Nitin. It was a pleasure talking to you.